I was like, they're religion.
Why would you even want to cut it?
Ahem. Ladies and gentlemen, phones away. Hobbs, give me the last 2 minutes. I will talk to you about how you can cut a donut in fourths an infinite number of times and end up with a third.
Okay.
It's one of the biggest.
Are those two in the middle really fourths of the donut?
We'll talk about that. The visual may be off. Oh, I forgot to tell you, discriminant. The dirty trick they pull on you is they'll ask the number of solutions. You'll look up there and you won't see any of them because they will have 0 real solutions. If there's 0 real, that means you had how many imaginary? 2, right? So if you go b squared minus 4ac less than 0, ACT, SAT sometimes will throw a dirty trick at you and say 0 real solutions, which of course means there's 2 imaginary. Okay, goal for today, given a radical equation. And notice we are going for equation today, not expression, so it's going to be equal to something. Given equation, find the domain and range.
Are we going over the homework?
You guys had homework? I'm pretty sure you guys didn't. Didn't we go to the? Oh, we didn't. Bad news bears. Yeah, because we went to the computer lab last time to get ready for Park. Given a radical equation, find the domain and range. And number 2, given a radical equation. So I guess no, we're not. Hill, sorry. Given a radical equation, you have to be able to graph it. Right. First, we are going to go back to the familiar and then go into the new stuff that we're going to talk about today. We're going to go back to our old friend, the quadratic. As you'll notice, I'm comparing what we're doing with radicals to an old friend quadratics because radicals are just the inverse of a quadratic. Quadratics, we had our old friend y is equal to x squared. If we plugged in some values to graph it, if we plugged in some old friends to graph that puppy, oh, let me give you 5 seconds of your own. Plug in those numbers. What do you get out? And then graph that puppy out. Plug in those numbers. What do you get out? And then take that puppy out. Plug those puppies in there. What do you get out? If you have a second and don't have it out, you will need your calculator for part of today. Yes.
What did it say about transformation?
Nothing. You haven't got that far yet, Latanzi. Good job of
What is it saying about y equals x?
quadratic. Familiar. Of course. All right, let's call some volunteers who hasn't talked yet today. Janelle, if I plug in -2 squared, what do I get out? 4. Good job. Why is it not negative? Bingo. Good job. Plug in -1. Braden, what do I get out? 1. Who has escaped the wrath today so far? Grace, if I plug in 0, what do I get out? And 1. Megan, if I plug in 1, what do I get out? 1. And who else hasn't talked yet today? Sam, if I plug in 2, what do I get out? 4. Now, nicely, it reflects through the x-axis. The biggest number we have to deal with is 4, so I label each side up to 4. The visual gives me the solutions, but gives me a way to look at them. So I look at all my solution points, 0, 0, 1, 1, 2, 4. I connect the dots. And remember last time we called this shape a what? Parabola. Why? Because we definitely weren't talking when Beckham was talking. We had our parabola. Give you a hint today. I didn't give this last period, but I should have. These are inverses. One undoes the other. Squared undoes square root undoes squared. They reflect through the line y equals x. Through the line y equals x, we're going to have something that kind of looks like this down here. Something that kind of looks in that area. Hi, Molly. We're going to have something that kind of looks like that because it reflects over that line. Why has it not got both parts? We'll talk about that too today. Our parent function for that was y equals x squared. We transformed that by vertically stretching it, moving it left and right. We remember back from the glory days that a was a vertical stretch. If a was greater than 1, it was a vertical compression. If a was less than 1, what about if a was exactly 1? Yeah, multiplying by 1 does nothing. And a does have to be bigger than what? Well, 0, because if it's bigger than 0, if it's smaller than 0, we're in trouble. We got a negative. We talked about that, though. It reflects it over the x-axis. The h moves it left or right, but it's on the inside, so it's opposite. The cool part about this is it really didn't affect our domain because we can plug in any number and get an answer out for this puppy. Moving it left or right doesn't affect the ability to plug in every number. K moved it up or down. Those same rules apply for today, and I'm just briefly glancing over that because I will spend a lot of time talking about that today. We are going to talk about domain and range today, as the first goal says. Domain and range are hard. That is something you just got to talk to yourself through. You got to talk to yourself in front of your mirror. I tell my Calc 2 kids a lot. Sometimes you got to do it 3 times for it to make sense. Domain and range is one of those things. It is purely a concept. It is not really a content. Purely a concept, not really a content. Stretch, compress if a is between 0 and 1.
So that stretch A is greater.
Right. If I take Lily and I multiply her height by 2, I'm stretching her out. If I multiply her half by 1/2, or multiply her height by 1/2, I'm compressing her down.
Okay.
If I multiply her by a negative, then I'm flipping her upside down and then either stretching or compressing based on what number's left. Yep.
What did it say to the right of the side?
Inside, it moves it left or right. Can I take this off?
I think you spelled compression wrong.
No, it's compress and then 0 less than a less than 1. Okay, so today, what are we going to talk about? We're going to talk about our new stuff. That was an old friend. Now we've got a new friend. Our new friend is the radical function. It's so radical. As always, we provide a rigorous definition of a radical function. It's a function with a root inside. But we have something that we're asking, what number times itself 3 times is equal to what's inside? With the square to cube, we are multiplying that number. Now we're undoing that. We're doing the reverse of that. And of course, a function means we plug one number in and we get. That was a question to you all. We plug one number in and we get one number out. Right. If we get more than one out, it's not a function. And again, going back to real life, if I asked you what you had Silver 8, you said honors algebra 2, I'd be like, oh yeah, that's cool. If you said, oh, I have honors algebra 2 and pottery at the same time, I'd be like, oh no, you don't. That's not a function because I asked you one question, you gave me 2 answers out. My domain didn't map to my range. If I asked your parents what they had Silver 8, what would they say? Yeah, I don't have it because they're not part of the no. They're not part of the domain, right? You plug them in, you don't get an answer out. It's like getting an imaginary number inside. You don't get an answer out. That's what the domain is. I didn't give this definition last period. I thought I could get away not doing it, but I need to. Domain is the values of the input that result in an output. And of course, we mean a real output, not an imaginary one. If your parents ask who your date is and it's an imaginary one, they're probably not going to be happy when you show up with them to, go out to dinner. Unless they give you a graphing calculator, right, Anthony? Your imaginary date gives you a real calculator. That worked out for you.
I would be the one imaginary date.
No. Don't worry, girls will talk to you once you turn 22. Values of the input that result in an output, the range is the range values the output gives. So let's pretend real quick. Input, output again, making it real life before we make it with math. If I asked all of you how much you plan on spending on savings. Well, hold on. The input is people that would give me a what? An answer. Does it have to be a good answer? No, it just has to be an answer. So if you're not going to Sadie's and I ask you, you'd give me an answer of what? $0, probably. Is that yet an answer? Yeah, it is. If I ask your parents, hey, no, I wouldn't ask your parents. I asked the guy who lives next door to you that doesn't have any kids and has nothing to do with the school, hey, how much you planning on spending on Sadie's? He would ask me what the math is Sadie's. Right. Is that an answer? No, because he's not part of the what? Domain. That would be the people who are going to Sadie's. Now, I could ask your parents. They might give me a confusing answer, because if I ask your parents, like, oh, $750, my daughter bought this crazy nice dress for it. I'd be like, really? You're spending that? And you'd be like, yeah, I bought it for her. Okay, that's kind of awkward, but they're still in the domain. They're spending money on it. So the domain is the values of the input that result in an answer, that result in an output. Not everything you plug in gets an answer, especially when you have a square root. You have to worry about where the what would not give you an answer if the what was what? What's a fancy word for the stuff inside of the square root? The radicand was negative, right? Then it wouldn't give us an answer out. So that would not be part of our domain because it does not give us an answer out. So again, domain is the values you plug in and get an answer. The range is the values of the answer you get. So again, if I'm asking how much you're going to spend on Sadie's, probably the lowest number I'd get would be, and the highest answer I'd get would be infinity. Really? You're going to spend you're spending an infinite amount of money on a high school Sadie's. What do you think the highest possible would be? $4,000. Okay, $4,000. Yeah, that better be. Whew, like a car. Yeah. That's typically if you ask somebody on a date, you are asking to pay for that because you're asking for the privilege of them going on a date with you. Like, Sophia, if some boy asked you out, they should be the one who are desiring your company. They should be the one paying for it. If you want to split it 50-50, then that's like hanging out. That's not a date. So if you ask some boy out, yes, you should pay for dinner because you are asking for the pleasure of his company for the evening.
So much money on their proposal, then what's the point of spending?
What are you doing for the proposal? And number two, why are you getting engaged? You ran this by your mom yet?
I'm doing it tonight. Yeah, I read it. Where did you find
No, by your mom.
Oh, where did you find them?
Your mom.
Young Life gave me 200 of them, and then I bought like.
Young Life gave you $200 to ask somebody to say, okay.
No. I'm putting balls in his room, like the balls are in the ball pits.
Yeah.
I put a bunch of.
I have little kids. I know what that is.
Yeah. I have like.
We call it the
500
cesspool
of
of
those.
disease and
I have like 500
influenza.
of those in my trunk, and I'm gonna fill up his entire room. And then my sign says, "I finally found the balls to ask you to sing." I said exercise balls, and then I realized that was not good.
Okay.
Because even though he was the one that told me that.
Who are you asking? The homecoming?
No,
Okay.
he got asked by someone else.
Who did you get asked by?
Kendra.
I don't know who she is. Was it as good as the way he asked you? Was the fire department involved?
No, if I asked him, it would have been way better. Like, but I'm asking Von Love.
Oh, all right. So there's a reason I only chaperone prom. Delta X is much greater than 0 prom. Okay, so let's go through today. We're going to talk about radicals. What do we have to worry about radicals? Radicals, as you guys stated, we have to worry about what's underneath the square root. Reminder, if we have like the cubed root of, let's go x squared plus 7. Let's just remind ourselves of some vocab here real quick. That 3 is the index. It's how many things you have to take one out, how many repeated multiplications you have to take one out. X squared plus 7 is called the radicand. Today, though, we are just going to talk about even roots or square roots. If I don't get to cube roots, I'm okay sending you to pre-calc without that. I'm not okay with you really not understanding what domain and range mean, though, which is why that's what I'm emphasizing today. This does work for square roots, but it really works for all of them that have an even index, not just square roots. So let us say we have the square root of x minus 7. Now, here's my question to you. First, I want to find the domain. And let's go back up. Our rigorous definition is that's the values of the input that result in an output. So we want to find the values that give us an answer. What kind of values give us an answer? 30 seconds, talk to the person sitting next to you. Ready, set. What values of the answer, or the values of the input x, give us an answer? Ready, set, math. 30 seconds, go.
So, for like 11, that means that it's 11 minus 7. The square root of 4.
All right, volunteer. Volunteer, yes, Marin.
It has to be above 7, so that way you don't.
Okay, so she says X. Oh, hold on. Whew. Marin, apparently you're a very popular name amongst the boys in this class. X has to be greater than 7. Let me ask you a question. What if it's exactly 7? Is that okay or not okay?
I guess okay.
Okay, I guess okay. What's 7 minus 7 first?
0.
What's the square root of 0? Is that an answer? Yes, so it has to be greater than or equal to, right? So any number greater than or equal to is going to make the radicand what? Positive, right? And that gives us a solution. Any positive radicand gives us a solution. Now you may say, well, what about like the square root of 17? Well, that's a messy answer, but yet an answer. Is the square root of -4 an answer? No, that's imaginary. No. So what do we do to find the domain? In the general case, we set the radicand, the thing underneath the square root, greater than or equal to 0, and solve. How do we display our answer? Well, there's two ways. There's an inequality, or there's an interval, because the smallest number we could plug in is number we could plug in, 7, and the largest number we could plug in is infinity. Infinity always gets a parenthesis because you can't actually plug in infinity. It's a journey, not a destination. So you could plug in numbers. What about 7? Can you actually plug in 7? Yes. So that gets a bracket. Bracket means you can actually use that number and get a solution. Parenthesis means everything up to that, but not including it. Well, infinity isn't a number. It's a journey, not a destination. In fact, it's a concept. It's growth without bound.
What's the highest number we know?
Infinity.
It's not a number.
Okay, mathematicians really aren't interested in the largest number. They're interested in the largest what? Prime number. And I've heard it's out to 17 pages now.
Oh boy.
Yeah, it's pretty big.
That's what people do.
They figure out, in fact, there's a book over here. Where is it? I think I loaned it to Arjun. But there is a book over here that's just, it's math with no real life purpose. It's called Number Theory. It is a class I had to take in college. I think I did loan that to somebody. But all it is proving properties of numbers just to learn about numbers. Like there's no real life application like it solves hunger or, stops global warming or any of that. It's just like learning cool things about numbers. But yes, that is what people work on, large operands, ways to find numbers that are not divisible by any number that's less than that.
Do they get paid for that?
Well, they're usually university professors, so they get paid to teach class, and this is what they get to do when they're not teaching. And just FYI, you'll learn when you go to college quickly, there are two kinds of profs. There's profs that like teaching, and there's profs that have to teach to learn so they can do this stuff in their fun time and still get paid for it. Why'd they steal your work?
Yeah, I think it was Mr. Burke said that sometimes, like a professor, since it's like a research type of thing,
Yep.
if like you find something really cool, then they'll say like, I'm gonna use this. And really take
Yes, that's called PI, Principal Investigator. And the bad news is, in fact, I'll show you mine from college that my professor stole from me.
Oh,
What's up?
Typically, if you work for them, they get credit for it. So the bad news is this is my thesis from college, which I published in like a math education journal. And just so you know, it's about 147 pages. And yes, when I went to publish it in there, suddenly my name was no longer first. Her name was, even though typically if you're co-investigators, you go in alphabetical order, and Beckman comes before Clarkson, but not when she's in charge. So yes, there are worse crimes, because if you're basically that person, you work for them, and if they don't say yours is okay, you don't get your degree. And it took me 1.5 years of work for her to sign off on it.
so like, what if a student, like a med student, is like trying to find, will they find the correct answer?
Mhm.
Does the prof just say like, oh man, like that was under my supervision?
Yeah.
so go
Well, you were under their supervision. It's not like you founded the University of Minnesota and got the University of Minnesota to pay for you to do this. The University of Minnesota paid for your tuition. You learned that or did that while you were learning there. So yes, they will typically get credit for it. Bad news, if you discover something awesome, keep it to yourself till you're out of school. Yeah, Greg.
So what's after trillion?
Quadrillion, quintillion, pentillion. Basically, though, Hill, if you have that much money, you call me up and I'll help you deal with those issues. So there's our domain. There's how we display it. Questions on that before we go on? Let's have you do an example. This is example 1, I think. Let's look at y is equal to the square root of 3x minus 19. What I'd like you to find is the domain. Oh, actually, here's what I'd like you to do. 2 things. Number 1, find the domain of this, and then number 2, plug that into your calculator. Plug this, find the domain of this, and then plug that into your calculator because we're going to figure out what the range is. Ready, set, math. I don't know if I have another one, Hadley. Better question. Why don't you have another one?
Because
I understand that, but why hasn't the boy given me one?
because I already have the best one out there.
Yeah.
You have to split that, that's the last one.
Oh, there's one in the drawer. Cameron's got one in the drawer for you. Look at that. And at Easter.
Anybody?
Squeeze 2 things in 9 minutes. 2 things in 9 minutes. Volunteer, what do I do to what do I do first with this? No. Volunteer, yes, Braden. Bam! Look at you using that math vocabulary too. 3x minus 19 greater than or equal to 0. How do we solve that, volunteer? How do we solve that? Savannah, yes, please. What do we do first? How do we solve that puppy for x? Now, here's the good news. Solving an inequality is the exact same as solving an equation, except if we multiply or divide by a negative, we have to flip the sign. So if that was an equal sign, what would you do first, Savannah? Boom. Somebody looks smart. What's 19 plus 0? Okay, greater than or equal to 19. Next step. Somebody else, somebody else, somebody else. Sophia, yes, please. Okay, so the domain of this puppy, x has to be greater than or equal to 19 over 3. Or another way of saying that in interval notation, we could go from 19 over 3 to infinity. Now, we're going to talk about the range in a second. That's the smallest value we can get for an answer to the largest value we can get to an answer. But before we do that, questions on how to find the domain of that puppy. How to find the domain. All right, let's take a look. We plug this one in our calculator. We first go to y equals. Yay, y equals. And notice, oh, I already have x minus 7 in there. How do I look at that? I go to zoom, and then which zoom do I typically pick first? Zoom standard, which is number 6. That gives me a good place to start. Maybe I need to zoom in, maybe I need to zoom out, but that's a good place to start. And notice, it kind of looks like half of a what? Yeah, half of a parabola or half of a circle turned on its side, because it's the inverse. It's reflected through that line, y is equal to x. Okay, now, what's the smallest value we can get for an answer? Do we look at x values or y values? Y values. Here's one way to do it. Look up, look up, look up. I could just trace over to the x-axis and see what the smallest one is. Or another way I could do this, I could go to, let me change mine real quick. I could go to the table, which is second graph. Second graph. And no, what is this nonsense?
Error.
Why?
Because you can't equal that.
Yeah, they're not in the domain, right? They're not in the domain because they give us what kind of answers? Imaginary ones, right? And no, okay, now I go to 7, which is the start of my domain. Good news, that's where we start getting answers. And what's the smallest number I get? 0. And then from there, what does it seem to be doing?
It's going up.
Yes. Does it grow without bound?
Yes.
Yes. So it will eventually go to what? Infinity. Yes. Great. Second, then go to second window. Oh, no. Go to y equals. Do you have square root of x minus 7 in there?
Yeah.
Okay, give me just a second. I'll come take a peek. Okay, range. For that one, the range is from 0 to infinity. Or another way of saying that, y is greater than or equal to 0. So the answers we got out. Remember, we asked the question, how much are you going to spend to Sadie's? Our domain was the people going, or the people who went to DCC. The range was the answers they gave us. For square root function, it starts at 0, goes up to infinity. So now let's talk about parents. Our initial graph. Our parent graph for a quadratic is y equals x squared. Our parent graph for a radical is y is equal to the square root of x. That has a domain of 0 to infinity and a range of 0 to infinity. What's the graph look like? It starts at 0, 0, and slowly, oh so slowly, goes to infinity. Oh so slowly goes to infinity. It's still going to get there. It's not going very fast. But it's still going towards infinity. Yes,
It will never get there.
Oh, no.
What's that?
Wouldn't it never get there?
We'll get there. It grows without any bound. There's nothing that's keeping it down.
But if infinity is without bound, then it will never get there.
It will, but it's going towards there. Its growth without bound is infinity. It's not somewhere it's getting. It's a journey. It's growing without anything stopping you from growing. Like imagine this, Mr. Gray. You meet the one, and I mean the one. And every time you go on a date, that is weird. That is weird. Fix it. That was weird. Every time you go on a date, you just fall farther and farther and farther in love. And every time you see them, your love for them just keeps growing. Like yesterday it was 972%, and today it's 1,016%. And every single time it keeps growing, that is what infinity is. It's growth without anything keeping you from growing. Like, they ask you to take out the garbage, you do everything every time, so it just keeps growing without bound. Yes, Anna. How'd I get the range? What's the smallest answer I could get in the y column? And what's the largest answer I can get in the y column? It just keeps going up, so it's infinity. Like if I was going to ask you how much you were spending on Sadie's. If somebody said 0, that would be my smallest value. If somebody said 8,000 and that was bigger than anybody else, my range would be from 0 to 8,000.
I'm spending infinity on
Yep. The only difference, the only thing that's going to take that is just like y equals x squared, the familiar one at the start, we could have transformations. What's the transformed equation of this look like? Y is equal to a times the square root. I'm putting b in there. Need to remember to do that next period. Hi. No, next door in Rainford's. Okay, there's the b in there, but we're not going to talk about it today. No b today. What do these do? Just like before, if a is greater than 1, it's a vertical stretch. If a is between 0 and 1, it's a vertical compress. That does not affect the domain or the range, though. Does not affect the domain or the range.
How do you get y equals x or y equals?
That's the parent function. That's like the most generic radical function we can have. That's like the base that all other ones are made off of. The transform version is now we've messed with it. We've moved it left or right. We've compressed it vertically, or compressed it. See, what's that going to do? It's going to move its opposite, so it's inside, of course. And it moves everything left or right, including the domain. So in other words, if your domain is normally 0 to infinity and you move everything to the right 5, your domain is at 0 to infinity. Now it's 5 to infinity. Right on, Savannah. D moves everything up or down, including the range. So let's go for our last example. I am a little pressed for time, but let's squeeze this one in there. Okay, what's the domain and range of that puppy? What is the oh, you can't see it. Minor detail. What's the domain and range of that puppy? Julie. Inside. The 4 is not inside, it is outside.
Is that the index or is that just the?
No, that's not the index, that's multiplied by 3. It would be a tray tiny 3 if it was the index. All I'm asking, what's the domain of the range? What's the domain of the range? It's the domain and the range. And if you're the kind of person that needs homework right now, we are not done. We are giving you your money's worth. Okay, what's the -2? It moves everything to the right 2. So the domain's not going to be 0 to infinity. It's going to be 2 to infinity because it went to the right. So it's 2 to infinity for the domain. The +4 moves everything what? Up 4. So it's not 0 to infinity. It's 4 to infinity. That's all we got to know for tonight. That's all we got to know. Ladies and gentlemen, sorry for the press time. These Thursdays, there is some fun work for you tonight. I will remember to text that out before I take off today. Have a wonderful day.